welcome to another week of digital learning. This week we are going to work on, hi Shiva. This week is not really like the others. We are starting our live classes, which I'm so excited about. I can't wait to see all of you there. At the end of the video, I will give you the schedule and remind you a little bit about what it is that is changing on Monday. But for right now, let's focus on radicals. Those are our square roots, our cubic roots, and the variables that might appear with them. Remember, you need your piece of paper and your pencil so you can go ahead and take notes and send a picture to me when you're finished. Let's go ahead and get started. See you soon. The number in front of our radical is always called the coefficient. It is also the coefficient if it is the number in front of a variable. The little 3 that we have here inside the radical is our index, and the radical is the sign itself. The 6 represents our radicand, anything that stands under the radical sign. Let's talk about some basic roots. When there is no index, we assume it is the number 2, which means that I am looking for a number multiplied by itself 2 times that will give me 1. Well, this group of 2 ones represents the answer 1. The square root of 1 is 1. And the square root of 4 is 2 because 2 times 2 is 4. The same with the square root of 9, 3 times 3 is 9, and the square root of 49, 7 times 7. The square root of 68 is 8 times 8, so the answer is 8, and the square root of 81 is 2 groups of 9, 9 times 9, which is equal to 9. Let's do some more basic roots. The square root of 16 is 4, and the square root of 100 is 10. All of these examples contain 2 groups of that number because the index is 2. Now let's talk about cubic roots, fourth roots, and other types of roots. Here I am looking for what number multiplied by itself 3 times will give me 8. So let's look for the prime factors of 8. 8 divided by 2 gives me 4. And I can then divide 4 by 2 again, and that gives me 2. 2 can be one more time divided by 2, and that gives me 1. So the prime factorization of the number 8 is 2 times 2 times 2. We have a group of 3 2's, therefore the cubic root of 8 is 2. Let's try that again with the fourth root of 16. What are the prime numbers, the prime factors that multiply to 16? We are looking for a group of 4. 16 can be divided by 2 and it gives me 8. 8 divided by 2 gives me 4. 4 divided by 2 gives me 2. And 2 divided by 2 gives me 1. Here we have the prime factors, the numbers that multiply to 16. 2 times 2 times 2 times 2 is 16. And since we have a group of 4 of the same number, 4 2's, my answer for the fourth root of 16 is 2. Let's take a look at the cubic root of 27. We are going to use the same method to find the prime factorization of 27. 27 cannot be divided by 2, but it can be divided by 3, which gives me 9, and 9 divided by 3 gives me 3. Divided by 3 again, it gives me 1. So 3 times 3 times 3 is 27, and therefore the cubic root of 27 is 3. The fourth root of 81 requires us to do the exact same process. 81 can be divided by 3. 3 times 27 is 81. 27 can be divided by 3, it gives me 9, and 9 divided by 3 gives me 3. Finally, 3 divided by 3 gives me 1. So the prime factorization here is 3. Radicals can also be written as fractional exponents. The index here in the first example, in the square root of 2, is 2, and there is an invisible exponent of 1. So we are going to write 2 to the first power. We are going to write the radicand that is inside the radical, and we can divide it by the index, we can divide it by 2. Therefore, the square root of 2 is the same as 2 to the 1/2. Let's take a look at the square root of 3. There is no index, so we assume it to be 2, and there is no exponent, so we assume it to be 1. 3 to the first power is the radicand divided by the index, which is 2, is our final answer. The square root of 3 is equivalent to the exponential fraction 3 to the 1/2. Now, let's take a look at the square root of 4. Many of you may say, yes, this is 2, because I know 2 times 2 is 4. But let's take a look here. 4 to the first power divided by 2. That is also equivalent. 5 square divided by 2 is a little bit more work. What is 2 divided by 2? Well, 2 divided by 2 is 1. $2 for 2 people is $1 each. And 5 to the first power is the same as 5. Therefore, I can say that whenever I have a square root and a square, they cancel each other. They are opposite operations. Let's take a look at 2 to the 6th power. That is our radicand, and we are going to divide it by the index 3. 6 divided by 3 is 2. So I have 2 squared, which is equal to 4. The cubic root of 2 to the 6th is 4. And I can see that because 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2, 6 times. And I can make one group of 3 2's and another group of 3 2's, that is 2 times 2, which is equal to 4. Finally, we have the nth root of a to the n, which is equal to a to the n divided by n. We have the square root of 7, and I know it is a square root because my index is 2. I can simply cancel out the square and the exponent and be done. Or I could write my radicand, 7 squared, divided by 2, my index, and 2 divided by 2 is 1, so 7 to the first power is 7. I can also notice that 7 squared is 7 times 7, and one group of 2 7's represents the answer 1 7. Each group represents its number. The cubic root of 2 to the 3rd is the same. You could say 2 to the 3rd power divided by 3 is 2 to the first power, which is equal to 2, or you could cancel out the cubic root and the exponent 3. This is because 2 times 2 times 2 gives you a group of 3 2's, which represent a 2 as an answer. Finally, the fourth root of 5 to the 4th power is 5 to the 4th power divided by 4, and you get 5 to the 1st power is equal to 5. I could also write 5 times 5 times 5 4 times, and that group of 5 4's represents the answer 5. Now let's take a look at example 2, where we have the square root of 5 to the 4th power, which ends up being 25. The reason for this is that 5 to the 4th power divided by 2, 4 divided by 2 is 2, and 5 squared is 5. This is 2 groups of 5 times 5 when I write it out. Let's try the cubic root of 2 to the 9th. I write my radicand 2 to the 9th and divide the exponent by the index 3. I get 2 to the 3rd power. 2 times 2 is 4, and 4 times 2 is 8. So 2 to the 3rd power is equal to 8. You can also write 2 times itself 9 times, making groups of 3 since the index is 3. 2 times 2 times 2, 2 times 2 times 2, and 2 times 2 times 2. I have created 3 groups of 3 2's each, therefore I am going to say 2 times 2 times 2, which is 8. Finally, let's take a look at the fifth root of 3 to the 15th. I can say 3 to the 15th divided by 5, which is 3 to the 3rd. That means 3 times 3, which is equal to 9, times 3 again, 27. I can also write 3 15 times, making groups of 5. I have 3 groups of 3 5's each, therefore 3 times 3 times 3, which is 27. Now let's take a look at the square root of 3 to the 5th. We can write this as 3 to the 5th divided by 2. But the problem here is that I can't really simplify that with a whole number. So I'm going to try writing out 3 times 3 times 3 times 3 times 3, making groups of 2 since my index is 2. When I do, I see that 3 times 3 is 9 and the square root of 3 remains. So my answer is 9 root 3. Let's take a look at the cubic root of 2 to the 10th power. When I do 2 to the 10th power divided by 3, the same issue occurs. I cannot divide 10 divided by 3 without decimals. And I definitely don't want that in my exponents. So let me write out groups of 3 2's each time. And I need 10 2's in total because I have 2 to the 10th power. The first group of 3 2's represents 1 2, another 2, another 2, and the cubic root of 2. Therefore, my final answer is 2 times 2 times 2, which is 8, cubic root of 2. Yay! No longer sad. Finally, let's do the square root of 27. 27 to the first power divided by 2. There's not much I can do here again. But I am happy because I know exactly how to handle this. 27. I have a couple ways to go about this. What are the factors of 27? 9 times 3 is equal to 27. The square root of 9 is 3, and the square root of 3 remains. Another way to do it is to find the prime factors. 27 can be divided by 3, which gives me 9. 9 divided by 3 gives me 3. Divided by 3 gives me 1. And here we go. Our prime factorization is 3 times 3 times 3. So when I put this into my radical form, what I see is that 27 under the square root is the same as 3 to the 3rd power. And I can create groups of 2 because my index is 2. The square root of 3 square, or 3 times 3, is 3. And the square root of 3 remains as the square root of 3. Let's consider the fourth root of x to the 5th power. That can be rewritten as x to the 5th power divided by 4. And I'm happy because I know what to do. Since my index is 4, I am going to create groups of 4 x's. Out of the 5 x's total that I have, I can put 4 in one group and 1 is left under the radical. These 4 are going to represent 1x, while the fourth root of x will remain the fourth root of x. And our final answer is x times the fourth root of x. Our next problem is the cubic root of x to the 4th power times y to the 3rd power. Let's take care of the x's. That's x to the 4th power divided by 3, and the y is y to the 3rd power divided by 3, which turns out to be 1. Now let's take care of x to the 4th power divided by 3. I can create groups of x's. This first x times x times x represents 1x, and there is an x left inside our radical. With the y's, I only have one y left. So my final answer is x times y times the cubic root of x. This is the order we usually like things to be in mathematics, but the previous square works too. Finally, the square root of 20 times x squared is 20 to the 1st power divided by 2 because our index is 2. Times x squared is also going to be divided by 2 because of our index. Notice that 2 divided by 2 is 1. So when I write my answer, I will have an x outside of the radical just like I did with the y previously, because y to the 3rd divided by 3 is the same as x squared divided by 2. Those exponents become 1. Next, 20 is 4 times 5. So the square root of 20 is the same as the square root of 4 times the square root of 5. And I know the square root of 4 is 2 times the radical 5 remains. So my answer is 2x times the square root of 5. I can also use the factorization method. 20 divided by 2 gives me 10, which I can divide by 2 to get 5, and divide 5 by 5 to get 1. So the prime factors of 20 are 2 times 2 times 5. I notice that the square root of 2 times the square root of 2 repeats, and when I multiply them, I get the square root of 4, which is equal to 2. While the square root of 5 remains because it is a prime number and it can no longer be simplified. Therefore, if I go back, I can see that 2 root 5 is the same answer, and I cannot forget that x. I hope that clarified any questions you still had. If you have more questions, please email me, call me, text me, get in touch with me, or any adult here at school. And one more thing before we go, remember that if you or your family, anybody that you know of, is in need of financial support, there are some resources in week 6. I will post them again in week 7 so you can take a look at those again. And feel free to spread the word because we don't want anyone in our community to not have what they need in order to succeed in school.